Hi, this is Prasanna from Wave Academy. Welcome to Matlab Basics Edition. In this video, we are going to discuss about basics of Simulink in Matlab. Actually, Matlab is very famous for model-based design. In that Simulink, we are going to discuss different types of test signals used in electrical systems like step signal, ramp signal, parabolic signal, impulse and sinusoidal signal. I am straight away moving on to the Matlab. If you want to open a Simulink, two ways you can open the Simulink page. Either you can click on this icon, it will take you to Simulink page. Otherwise, just go to command window. After this prompt, you can type Simulink. It will take you to Simulink start page. So in the start page, you will be having a blank model, subsystems, library, and what are all the toolboxes available in the Matlab. You can able to see that. So in that one, straight away go to blank model. Just click on create model. It will open a blank Simulink page. So it is always a good practice. Save the file first. So let me save it like it's a signal study. The extension of Simulink file is .slx. If you know what are all the elements available in the Simulink, you can straight away double click and go to search blocks. You can type whatever you want. Suppose if you want a sinusoidal waveform or if you want a DC machine. If you know the element name, you can straight away take it from the search block. Otherwise, go to library browser. You'll be having libraries. See, there is a Simulink, aerospace block set, audio toolbar, communication toolbox, vehicle dynamics, robotics. Likewise, you'll be having plenty of applications with the blocks. Okay, so in this one, we are going to discuss a very basic one. Just go to Simulink. If you want to know about the signals, go to sources. There will be two things. One is sources and sinks. Sources is nothing but it will act as a generator. It will generate the signals. Okay, it will act as an inputs to your systems. If you want to see the outputs, for an example, you can take XY graphs, scopes. You can go with the sinks. You'll be having a floating globe, floating scope, display, output port. If you want to record, scope, termination, you can use the sinks. So it's simple. Sources will act as a transmitter, whereas sinks will act as a receiver. So I'm going to sources. You'll be having different types of test signals. Step signal, ramp signal, sinusoidal signal. Actually, there is no parabolic signal and there is no impulse signals. You can generate it. So the first signal I'm going to use is a step signal. Let me add that model, add that block to the model. So we'll be having a step signal. So how actually it is working? If you double click the step, see the step time is 1, initial value is 0 and final value is 1. So how it is working? You can easily see this. Take a scope. If you want to change the background of scope, just go to view, go to style, make the figure color as white, axis color as white, pin color as black, channel 1, actually it's a step signal, make it as 3, it will be black, apply, okay. So simply connect the step signal to the scope, take the stop time of 5 seconds, run the system, you can able to see the output. See how it is working actually. The step time of is 1, initial value is 0. So it is starting from the initial value of 0 up to step time. Actually, x-axis will be time in seconds. Okay, up to 1 second, the output will be 0. Once the step time reaches 1 second, output goes to amplitude of 1 volts. So final value is 1. Suppose if the final value is 2, the same system will behave like this. See now, where it is settled in 2. This is the way actually the step signal is working. Okay. Now, I'm going to do one more operation. So what will happen if you integrate this step signal? Integration of step signal will give you a ramp signal. Take an integrator. Simply connect the step signal to the integrator. Now I'm going to integrate the step signal. If you want to see both outputs in a single scope, you can connect it like this. So the first input is step signal. Second input is, it's a ramp signal. Actually, this one is a ramp. This is step. Just get inside the scope, go to view. You can change the line style. Okay, let it be run. If you run the system, the integration of step signal will be a ramp signal. Let's go to view, go to style, take the ramp, change the color. Let it be blue. So it's giving you a ramp signal. It's an increasing slope. Ramp will be act as a slope signal. It's nothing but a slope. Again, what will happen if you integrate ramp signal? Take one more integration. Connect it here. This is actually parabolic signal. If you integrate ramp, it will give you parabolic. You can connect ramp here, and the third output will be, it's a parabolic. Okay. Integration of step will give you ramp. Integration of ramp will give you parabolic signal. Run it. You will get the output. You can see it here. Style. Let me change this parabolic as red in color. If you want to add legends, if you want to add X label, Y label, that is also possible. Just go to view, go to configuration parameters. Okay, go to time. Just click on show time axis label, and units it will be in seconds. Apply. Now you can see the time in seconds is up. As you can see it in x-axis. Similarly, if you want to know about, if you want to add Y label, go to view, style, sorry, go to view, configuration parameters, just go to display. Here you can make Y label. Let it be its amplitude in voltage. Take it as a, you can add title also. It's a test signal study. So this is the way you can add X label, Y label, title also. If you want to add legend, you can add it. Just click on the legend. It will give you. The black one is step, the blue one is ramp, and the red one is parabolic. Okay. So if you integrate a step signal, it will give you a ramp. If you integrate the ramp, it will give you parabolic. Suppose if it is a parabolic signal, if you want ramp, you can take derivative. You can go in reverse manner. If it is a parabolic, if you take a derivative of parabolic, this will give you ramp. If you take a derivative of ramp, it will give you step signal. Okay, what about the derivative of step signal? Derivative of step signal. This will give you impulse signal. Now you can see this. Take the same step. Take scope. Okay. So I'm going to take a derivative of step. So if we take a derivative block. So where you can find derivative and this kind of integrated blocks? Just go to library, go to continuous. You will be having integrator block, derivative blocks. Okay. So derivative of step signal will give you impulse signal. This one will be, it's an impulse. So impulse signal. Okay. So this is the way you can analyze the signals. We normally use these test signals in most of the electrical engineering applications to analyze the systems, to study the characteristics of systems. Okay. So at the same time, what about sinusoidal waveform? Just go to library, go to sources. You'll be having a waveform called sinusoidal waveform. Let me pick that sinusoidal waveform to my block. So you will be having a sinusoidal waveform. If you want to see the output, you can take a scope. If you double click this sinusoidal waveform, you will be having a lot of options. Okay, amplitude, bias, frequency, phase, sample time. If the sample time is 0, then it is a continuous sinusoidal waveform. If the sample time is greater than 0, then that is nothing but it's a discrete sinusoidal waveform. So both we'll see now. So first I'm going to use the sample time as 0. Let it be, it's a continuous sinusoidal waveform. I'm not going to change the amplitude, let it be 1, bias is 0. I'm going to change the frequency as 2. Make sure that the frequency is in radian per second. If you are giving the frequency in some hertz, okay, normally the unit of frequency will be hertz. You have to convert it into radian per second. So as of now, I'm using the frequency as 2 radian per second. Sample time is 0, which means that this is a continuous sinusoidal waveform. Just click apply, OK, and if you see the output, you will be getting a sinusoidal waveform like this. Okay. So at the same time, you can change the frequency. Let it be it's 10 radian per second. Again, run the system. If you see the output, you cannot accept that this is a sinusoidal waveform. Actually, there is no problem with the Matlab. It is a problem with the step size what you are using in model. Okay, how to change this as how to convert this improper sinusoidal waveform into a proper continuous sinusoidal waveform? It's very easy. Go to modeling, go to model settings. Okay, in that model settings, you'll be having a lot of options. Go to solver. In that, go to solver details. So change the maximum step size. Now it is in auto, right? Change it to 0.01. That means I'm increasing the number of samples. If it is auto, by default it will take 1 sample per second. Okay, so now I'm going to change the maximum step size as 0.01. So it will increase the number of samples to analyze. Click apply. Okay. Now again go back to simulation. Just click the run button. You'll be getting a proper pure sinusoidal waveform. Okay. So this is the way you can improvise your response. If you want to see in a clear manner, just go to style, change the background. Let it be its 2. Make it as some color. You'll be getting a pure output. Okay. So now I'm going to show you how to generate a discrete sinusoidal waveform. I'm getting inside the sinusoidal waveform. Just go to frequency, let it be its 2 radian per second. As I said earlier, if the sample time is greater than 0, the sinusoidal waveform will be, it's a discrete waveform. It will give you a discrete sinusoidal waveform. Now, as of now, I'm using it's a little bit, it's a 0.1 seconds as a sample time. Click 0, click apply, OK. So the moment you can able to see that it will give you a discrete output. Run the system. You can see it's a discrete sinusoidal waveform. Okay, so whatever the step time, I'm using it's 0.1 actually. It's a 0.1, 0.1, 0.1. So within that 1, we'll be having almost 10 points will come. Okay, so this is nothing but it is a discrete sinusoidal waveform. So I hope this video will give you a clear idea of what is step signal, ramp signal, parabolic, impulse, sinusoidal signal, how to generate the same signals with the help of Matlab. Thank you. Kindly subscribe to the channel. If you have any queries, kindly drop a mail to this mail ID. Thank you.